a scalar line integral. The other one is a vector line integral. I will not solve them all the way to the end, but I set them up. Is that fair game? Okay, I will probably set up just one of these and leave you for the second part. So when it's I know it's the function is scalar line integral. Look, it tells me one path goes from 0, 0. Can you see this little piece? And then goes to 1, 0, 0. Then from 1, 0, 0 goes to 1, 1, 0. Then it goes to 1, 1, 1. So there are 3 smooth paths, and then the connection between them is not smooth. It just has like a corner. So I have to solve 3 of them simultaneously. So first, let's see. C1 is so I'm doing the first step for all of them. Step 1, finding R. R is consisted of 3 pieces. They're basically piecewise defined, right? Except that at this point, we don't write it with that brackets in calculus 3 anymore. We just, there's this one piece and that one piece and the other one piece, right? You can write it as a piecewise defined shape. But so there's a C1, which is goes from 0, 0, 0 to 1, 0, 0. All I'm using here is this formula. I'm using the formula beginning point A plus T times AB. This is a good one for the line segment, because then I can say a line segment from A to B, because I can have T between 0 and 1. All good? What, Jose, did I not have a sign error? I did have a sign error. Okay, I just saw the chat, sorry.
Yeah, I figured that out later.
Did I fix it?
Yeah, I think so.
That's the last one. Okay, there we go. And so T is between 0 and 1. So for the first part, what do? What is point A? A is this, B is here. So I write R1 of T equal to point A, which is 0, 0, 0, plus T times point B minus point A. But point B minus point A is just point B, because the point A was origin. And T between 0 and 1. Then C2 is 1, 0, 0 to 1, 1, 0. So that's R2 of T. This is beginning point plus T times AB. So this is A, this is B, and AB is equal to 0, 1, 0, 0, 1, 0. And then C3 goes from point 1, 1, 0 to 1, 1, 1. So AB is equal to 0, 0, 1. R3 of T is equal to 1, 1, 0 plus T 0, 0, 1. So I parameterize every one of them. Are you guys going to be okay if I write it in the next page like this? Can you see this page? Okay. Why am I doing that? Because I want to find the R prime for each one separately. For C1, R prime of T is here. I can put all these together and I get, for example, for that one, I get T0, 0, right? But also I know R prime is just going to be what multiplies T. So I will have 1, 0, 0, R1 prime, sorry. R2 prime is going to be that one. R3 prime is just going to be that one. Everybody okay? Did I make an error? You guys are kind of pondering, I wonder. No, it's all okay? Okay. So I found all three of these. Now I have to parameterize. Let me put it this way now. Doing it, almost working. I have to parameterize F for each one of those. So for C1, let me write everything down here. This is 1, T0. That one is 1, 1, and T. So for C1, oh, sorry, it's a scalar line in a go. F of RT is going to be T squared is T squared. For C2, it's T squared plus Y plus, no, 1 squared plus T. Did I do it right? No. For R3, it's going to be 1 plus 1 minus T. So I found all those parameterization. You know what? I thought I was computing vector line integral, so I didn't find R prime of T. Let me go back. So here I completely, the magnitude. Magnitude is going to be 1. Magnitude of 2 is going to be 1. Magnitude of 3 is going to be 1. All of the magnitudes are 1. Now, write 3 integrals and just follow those lines basically. You have this line, and this line. So what do I get? 4, I have integral over C1 FDS plus integral over C2 FDS plus integral over C3 FDS, because it's piecewise defined. And that is, F here is T squared, right? R1 prime is 1. T squared dt from 0 to 1. Remember, the parameterization, each piece was so that the T would be from 0 to 1. Right? The dummy parameter was 0 to 1 for each one of them. And that was the trick, basically. The second one, F is 1 plus T, dt, 0 to 1, plus 2 minus T, 0 to 1, dt. And you compute. Please tell me that I did everything right. Yeah, I think it's a miracle. This one worked, I think. Everybody with me? So what were the steps? Each piece I parameterized. Each piece I found a magnitude of R prime. Each piece I found parameterization. I found little f at that parameterization. Each piece we parameterize, part 1. Each piece we found R prime. Each piece we found we evaluated f at r, ri basically, r sub I, and then we computed the entire thing together. And so what happens is that sometimes you're building a path but they're not a continuous function that goes. So you want to break it down into pieces of smooth function and smooth